Okay, so today I'm going to talk on bioprocess control and monitoring variables such as the temperature, agitation, and pressure. So this topic is we'll cover in 3 lectures where we will discuss in detail about the how the bioprocessing take place and uh, bioprocessing of the metabolites and secondary metabolites where we can process the bacterial and fungal cells in the different fermentation conditions to get the product. So first let's talk what is bioprocess control and why the bioprocess control is important. The bioprocess control involves precisely managing the physical and chemical variable or physical and chemical factors basically which are involved in maintaining the regulation of this bioprocess uh, machinery or bioprocess backup. Uh, and these variables are basically involved in optimizing the cell culture and for the maximum productivity. Because the basic idea here is that you have to produce the best quality and best quantity cell culture. And if this best quantity and best quality cell culture is not maintained, then the bioproduct will not be produced. All right. Now, in order to produce the best quality cell culture, we need to have certain factors to optimize these conditions for the cell growth, right, in fermentation. And this sophisticated discipline ensure the consistent product quality, product quantity, right, and maximum yield of the product, which is coming out from the bacterial cell or from the fungal cell, which are being used, and guarantee process reproducibility across the production cycle. So, what is more important here is that how we can produce or how we can reproduce the whole process of the maintaining and managing the controlling the whole bioprocess in order to get the best quality product from the cells. So in order to get the best property and best quality product, what is more important, and of course the quantity is important, that you need to have the good quality and good quantity of cells as well. So for in order to get the more cells to produce in this bioprocessors or in fermentation process, you need to have some optimization parameters. So from life-saving pharmaceutical to every food product, bioprocess controls serve as a foundation for the biotechnology industry, enabling reliable and scalable manufacturing of biological product. All right. Now, so we need to focus on all kind of industries like pharma industries as well as the industries involved in the biotechnology, food product industries, and several other product industries where we can get the processed food or processed product out of the with utilizing the cell growth. Now the stakes. What are the stakes? Why control matters, right? What are the basically why we are focusing on the control of this bioprocessing? So number one, in order to control these bioprocess, you need to focus on three major stakes. One is economic impact. That is how this product give you the economic impact on the product development. For example, even slight deviation in the temperature or agitation process of these fermenters, right? It reduces the yield by 20 to 40%. So if in a single batch the yield is reduced by 20 to 60% or 20 to 40%, or even in between, then you can understand, you can translate the millions in cost revenues for scale up this process. So in order to maintain the economy or in order to improve the economy, you need to have the good quality product, and therefore the economic impact is very important stake for controlling this bioprocessing. Then quality consequences, for example, yeast fermentation. The temperature shift from 2 to 3 degrees centigrade, right? Maybe plus or minus can cause the off flavor in beer, right? So you can see the difference. So you can have a beer of a good quality, and once the beer has been made, the batch of beer produce like a bad flavor beer or wine, then the whole batch will be either discarded or costs goes down on sale. So this is how the quality is matters a lot. So in order to maintain these parameters which are controlling the whole bioprocessing or regulating the bioprocessing of the cells product is basically very, very, very important. The pharmaceutical stakes is biopharmaceuticals with the billions depends upon the tight process control. If slight change in these process control, lost the whole kind of a product. But the minor variation can affect the drug efficacy and patient safety also, because patient safety is also important if the quality goes down or something else. So these three stakes are very important in order to regulate. So now, if the question comes why the bioprocess control is important, so answer is because of these three stakes, because the economic impact, the quality control, quality consequences of this product, bioprocess product, and the pharmaceutical stakes, which is very important because it like depends on these stakes, and depends on these stakes, the lives of the millions of people depends. Now, just introduction to bioprocess variable. What are these variables, and why these bioprocess variables are important, and how these bioprocess variables are basically involved in maintaining and controlling the bioprocess process. Now, the temperature, pH, agitation, oxygen which dissolve, nutrient levels, and pressure. These are like six major control variables in bioprocessing. So let's talk about the temperature. Temperature is it maintains the optimal enzymatic activity in bioprocessing, because in bioprocessing the substrate is being used to convert into the product. Whatever products are produced through bioprocessing in the cell, it also depends on the growth of the cell, which has been dependent on the temperature which is being given to the cell growth. For example, if a yeast, as I have given you the example, yeast, if slightly changing the temperature by 2 to 3 degrees centigrade, will affect the whole growth processing, and their, the quality of the product processing will be definitely affected by these temperature control. So directly it impacting the cell viability, product formation, and all these things are dependent on the temperature condition. Now, then dissolved oxygen, because sometimes oxygen is required, sometimes oxygen is not required, sometimes a different quantity of oxygen is required. So essential for the aerobic processes, right, for which without oxygen they cannot grow, they cannot produce the good quality product. So you have to ensure the cell receive the adequate amount of oxygen for the respiration and energy production. So for that, you need to have agitation processes one, then you have proper aeration process, then several mechanisms are used in order in the fermenter for bioprocessing these product using the oxygen as a best quality oxygen dissolved in the suspension. Now, pressure is another important parameter where it maintains the sterility, right? So non-desirable microorganisms can be avoided. It aids in filtration process also, how to filter. Then it impacts the gas solubility within the bioreactor, how the gas are solubilized. So pressure is basically put on these fermenter providing. So again, what sort of pressure, what is the total amount of pressure is required in like pound per inch square or per centimeter square or whatever unit you are using. So that pressure is important to maintain to regulate the bioprocessing. Similarly, pH is very, very important in order to regulate this, because pH, every reaction depends on pH. So if the metabolic processing is taking place at a particular pH, for example, slight acidic pH or basic pH or neutral pH, then if the slight change in the pH with a few points, like for example, if it is optimum pH is 7 or 6 to 7, then if it goes to acidic side like 5 or 4, it affect the whole process of like product development. And it also depends on, for example, product, like if you are working on some growth factors or some protein foldings process will be affected, stability of the proteins or stability of these product, if they are of lipid and protein natures, will be affected. So the control of these pH is very important in the particular range, so that you cannot denature the product or you cannot destabilize the product. Now, agitation is something linked with the dissolved oxygen, or agitation is linked for the aeration process, where It provides the homogeneous mixing also, so that each cells in the suspension or in the solutions can have like a proper in container or in vessels properly mixed together, and they can have interact each for the enzyme molecules which are used for the dissolution or which are used for the conversion of these product into the bioprocess product. It also enhanced the massive transfer of the nutrients and gas, to every nutrients or every substrate, so-called, on which the enzymes are working, and it prevents the cell sedimentation. So for example, if you put something in a vessels and in a vessels or in a container, then if you're not agitating it, if you're not like stirring it, then it will settle down in the bottom. For example, if you take a sugar and you just put the sugar inside the glass or inside the cup, and you don't agitate it, sugar gets settled down inside the base of this vessel, at the base of this cup or glass, and it will not be providing the sweetness to the whole solution, whether it could be a syrup or it could be tea or milk. Now, when you agitate it, when you stir it through proper spoon or through proper stirrer, then the molecule get dissolved in all over the glass, so that it can mix together and give you the sweetness even on the top part of the section of the glass, as well as on the bottom. Otherwise, what happens when you don't dissolve it, keep the sugar inside, they settle down. You can take one, two, three, four, five, multiple sips, and all sips are not sweet. But at the bottom, when it is almost finished, you find it very, very sweet. So that is because of this agitation is very, very important to produce the best quality product. The nutrient level again is important, because what sort of nutrients you are supplying and what are these nutrients is basically required for that particular microorganisms. This is also important because, for example, in certain microorganisms you need some salt required. In some of the microorganisms, what you need is not a salt, but the sugar is required. So you should know where the sugar is required and where the salt is required, or some other nutrients like vitamins and some supplements are required to provide the best quality product. Now, temperature's impact on bioprocesses, as I've just briefly discussed here, we can talk about in detail. The temperature serves as a master regulator in the bioprocesses, directly controlling the enzyme activity, because enzyme activity is dependent on the temperature. If the temperature is variable, then the enzyme activity will keep changing and the cellular metabolic processes rate will be affected. When the cellular metabolic processing rate is affected, then it will affect the product development. And each microorganism has its optimum temperature, right? Range, for example, if you talk about the yeast can have optimum temperature of 28 degrees centigrade. Bacteria may have optimum temperature 37 degrees centigrade, right? Similarly, some of the saccharophytes or extremophiles may have optimum temperature of like at the lower side or higher side, right? So these temperature regulation process is very important. Mammalian cells cultures typically require the precise maintenance of 37 degrees centigrade, while bacterial culture may thrive at different temperatures depending upon the nature of the bacteria, right? Similarly, the death rate may be increased in the different variation in the temperature process. So therefore, the optimum temperature need to be maintained or regulated in order to get the best bioprocess. How to measure the temperature? Because in order to regulate, in order to optimize the temperature, the measuring the temperature is very important, and you have to look into the technologies where the measurement is required. How to how to measure these temperatures, and technologies, sensor-based technologies are required. The thermocouples are thermostats are there, and these thermocouples and thermistors are basically produced at the machine in the meters in the machine where the fermenters are maintained. The fermenters are being used to ferment or to bioprocessing. So dominate the industrial application, because majorly we are focusing on this product on the level of industry. Generally, in laboratory scale, we can use the simple thermostats. Or thermometers can be used for that. So this provide the rapid responses time essential for the process control. What is the time required to maintain that temperature, and how long you can maintain that temperature, so that can be regulated through these machines, through these parameters. Or these parameters can be controlled through these instruments. The metal resistance thermometers. So again, the palladium RTD offers exceptional precise stability for critical applications and stability for critical application requiring accuracy within zero point 0.1 degree centigrade plus minus over extended period for a long time of period. So this is called the metal resistance thermometers. Now, integrated sensor system is modern bioreactors incorporate sensor directly into reactor jacket or immersible probes, enabling the continuous real-time temperature monitoring. Now, these integrated sensor are basically are inbuilt in the machine, where it can sense the uh, bioprocess product. It can sense the whole suspension media and nutrients where the process is going on to get the product from the microorganisms, and that sensors are basically get integrated. These are also sometimes nanosensors are also used for that. So these measuring temperature sensor in a real-time manner are at every point of time when the growth is going on. So you can also maintain the sustainable growth at the active phase, that we call the exponential or log phase, like this, rather than stationary phase, that can also be attained through this sensor at monitoring at the very real-time scale. Now, what are these sensors? Is basically precise temperature monitoring is a fundamentals in bioprocess success. So if you have precisely maintained the temperature, then you can have high quality bioprocess product can be attained. And different sensor technologies offer a unique advantage depending on the application specific requirement for accuracy, response time, and then operating conditions. I mean, how it get operated. For example, resistance temperature detector, we call RTD. So accuracy is high, like zero point 0.1 degree centigrade plus minus to zero point 0.5 degree centigrade plus minus. And the response is moderate. We call second to minutes. Within a second to minutes, it can respond. And application is fermenters, bioreactors, validation, critical temperature control. So these are all applications of these RTD sensors. Now, thermistors are basically fast. Within a second it responds, and accuracy is again 0.05 to zero point 0.2 degree centigrade, zero point 0.2 degree centigrade. And this with plus minus 1, plus minus. The application is a cell culture application, like cell line cultures, then small scale bioreactors and medical devices, narrow range. So all these, because they are also directly concerned related to the human safety or patient safety. Thermocouples are accurate with a moderate level, that is zero point 0.5 to 2 degrees centigrade with plus minus, and it responses are fast with a millisecond to second, right? Its accuracy is very high. Then application is autoclave, sterilization setup, and then exhaust gas and monitoring rapid changes. Then we have IR sensor or infrared sensor. Infrared sensors, their accuracy is 1 degree centigrade to 3 degree centigrade plus minus, and response is very fast in milliseconds. So this is very, very highly responded sensors. And application is non-contact surface measurement, where we cannot contact the surface, and sterilized environment conditions, and sealed vessels where we can seal some pharma products and some food products. So, what kind of a sensor to be chosen for these bioreactors or for bioprocessing is depend on what sort of product is required and what are the settings where you are using these sensors, temperature sensor, to regulate or to maintain the bioprocessing. Now, controlling temperature is a bioreactor, right? Uh, Heating, cooling system. This is water jackets provides uniform temperature distributions. Then we have internal coil system for rapid temperature changes, electric heating system like for precise control, and chilled water system for efficient cooling system. So this is how the controlling temperature bias reactors work both in heating and cooling. Check it. Now, why agitation matters? Now, agitation matters because it provides the uniform distribution of the nutrients, uniform distributions of the microorganisms, uniform distribution of the whole suspension where we are producing the bioproduct through bioprocessing or through in bioreactors. Uh, so to ensure the consistent nutrients, oxygen supply to the all organisms in the bioreactor and preventing the formation of the concentration gradient. So there should not be a concentration gradient. For example, some of the section of this is high concentration of a nutrient, some of the section is a less concentration. So there should not be any gradient top to bottom or bottom to top gradient, but it should be uniform. Growth should be a uniform, homogeneous growth is required. Then prevent the sedimentation process. So it will not allow to get sediment these settle down these particles or these cells, debris, the cells are these nutrients at certain zone for the limited access to the nutrients to the microorganisms. So they keep like moving, and it prevent the settling. It keep like moving and homogeneously in the whole vessels and the whole bioreactors, no matter how big and how small is it. The shear stress management is also important because balancing mixing efficiency with the cellular protection and excessive agitation can damage the sensitive cell membrane and reduce the viability. So, agitation sometimes the fast agitations are the more high frequency stirring or agitation may also put a shearing effect, mechanical shearing of these cells and these kind of a things, and it can lyse the membrane and cells might damage sometime like a sonicating effect. Now agitation parameters measurement. The key measurement parameters are speed in RPM, primary control variable for mixing intensity. So you have to look into the RPM, what the RPM of speed is required, rotation per minute or per, right? And impeller design is also what sort of impeller you have. You have a flat impeller, inclined impeller, or what is the structures and shape of the impellers. It also depends on the design of the impeller. So rustons and turbines, pitched blades like marine propellers, what kind of impellers you are using, it also depends on that. Then power input, what is the input of the power, indicates mixing efficiency and energy consumption also. Tip speeds, for example, critical for shear sensitive applications, right? So tip speed is also important. Now, advanced monitoring system use torque sensor also and motor current analysis. So what is the torque and motor current in a real-time feedback on mixing conditions when it is moving like this. So this is also important. I mean, it has an impact on the product development. So therefore, agitation matters a lot. So how to measure the agitation process? Through these parameters, you can measure. The modern sensor measures the mixing efficiency through oxygen transfer rate, providing insight into mass transfer, performance, and helping optimization of agitation strategies. Now, agitation and mixing principles. What are the agitation and mixing principles? So, Ruston turbine is basically high shear radical flow, ideal for gas dispersion, homogeneity of high viscous fluids, an excellent for oxygen transfer in aerobic fermentation process. Whereas the pitch balance is good for axial flow, medium shear, right? Because it required medium shears and promotes the bulk fluid movement and solid suspension, widely used for the suspending cells and preventing sedimentation without excessive damage. Whereas a marine popular used for axial flow again, um, low shear effect, creating a strong top to bottom current suitable for delicate cell culture and achieving good bulk mixing with the minimal cell damage. Now, the power consumption is agitated system is critical for energy efficiency and avoiding excessive heat generation. It depends on factor like impeller speed and diameters, fluid viscosity, and baffles accurate calculations, ensure cost effective operations, and so on. Now, the effective mixing directly enhances the mass transfer rate of essential component like dissolved oxygen and nutrients to the cell and the efficient removal of metabolic byproduct, and this directly impacts cell growth kinetics, means what is the growth rate in a limited time period, product formations based on the growth rate, and overall bioprocess productivity is controlled through this regulation of the agitation process. Now, the last slide is the balancing agitation. It's too much versus too little. So, how to balance the agitation process? Because as you have seen in the earlier slide, we discussed about the different design of the impeller, uh, nutrients, conditions, right? And the vessel's design also depends on the movement of the impeller, torque, right? Now, the excessive agitations means like it could have the sometime mechanical shearing effect on these cells. It causes sometimes damage to the cell. And particularly harmful to the mammalian cell. Suppose if you are working on the mammalian cells in the shaking conditions, cells may not adhere on the surface or on the suspension, because mammalian cells are grown on the suspension conditions. They are not put on the solid condition, right? Just like a bacterial cells and fungal cells. And these mammalian cells cultures results in the reduced viability and productivity when it is like more shearing effect. So therefore, the balancing agitation is very, very important. To what extent you have to agitate, and when agitation should be reduced in terms of like a RPM, torque, and other things. The optimal range is achieve uniform mixing, right? Whilst protecting cell requires careful characterization for each cell line and process condition. Insufficient mixing, right? Sometimes the nutrients may not mixed. Sometimes the gradients may not mix. Sometimes cells may not come in contact with nutrients to get nutrients for the growth, for the processing. And that might lead to heterogeneity, the loss of homogeneity in the suspension, and that affect the growth conditions, reduce the overall viability, reduce the productivity, reduce the processing of these products. And therefore, optimization strategies, optimization of agitation strategy is a very, very important in order to produce the yield in good quantity. Now, this agitation regulation and control, or balancing this agitation basically itself, besides other parameters, other factors, it can control, if it is controlled, then 20%, even up to 25% yield can be improved, right? And it can maintain the cell viability above 95% in the culture period. So this is all about the agitation, temperature, pressure, nutrients, conditions for how to balance, how to control, regulate the bioprocessing. So thank you very much for this lectures, and I have soon another lectures on the different topic.